Hello, students! Today, we're going to tackle a topic that often seems a little tricky, but is actually very logical. We'll be talking about the nomenclature of coordination compounds. So let's just jump right in with a question. Look at this complex ion. Now, your first instinct, right? You might be to name it starting with chloride simply because Cl comes first in the formula. But is that correct? This little question highlights exactly why we need a very clear set of naming rules.
So why are these rules so important? Well, think of it like spelling. When you write the word cat, everyone in the world who reads English knows exactly what you mean. Nomenclature is like that, but for chemistry. It's a universal spelling system that ensures a chemist in India and a chemist in Japan are talking about the exact same compound with absolutely no confusion.
Now, the entire system is built on 4 very simple steps. It's our roadmap. First, we identify and name the ligands. Those are the groups attached to our central metal atom. Second, and this is key, we list those ligands alphabetically. Third, we name the central metal itself. And finally, we just state its oxidation state in Roman numerals.
Here's a nice way to understand this. Think of a chemical name as a chemical passport. A real passport has a standard format, right? So everyone can understand it. In our chemical passport, the metal and its oxidation state are the core identity. You know, like a person's name and age. The ligands are the identifying features, the accessories maybe. And just like a real passport, our chemical name follows a very strict, non-negotiable format, the alphabetical order rule.
You see, before these standard rules from IUPAC were established, things were quite chaotic. A chemist in one country might have a completely different name for a compound than a chemist somewhere else. And this, as you can imagine, created immense confusion and made scientific communication extremely difficult.
Just imagine the problems this would cause. You'd have one single compound with many different names, which led to endless confusion and research papers. It became nearly impossible to communicate findings across different languages, and, what's most dangerous, a chemist could try to synthesize one substance but accidentally make another, all because of a simple naming mix-up. This is exactly why a single, universal system is so crucial for science.
Okay, to make this system truly intuitive, let's create a mental image. I want you to picture a grand masquerade ball. Everyone is wearing masks and elaborate costumes, and your job is to describe these guests in a standard way so that they can be identified from your description alone.
So, how would you do it? Well, the most logical system is to first describe the person's decorations, all their accessories, like earrings or rings. And to be systematic, you would list them in alphabetical order. Only after you have described all the accessories do you identify the person under the mask, let's say Lord Cobalt. And finally, you state his rank. For example, the third. This is exactly how we name coordination compounds. The accessories, which are the ligands, are named first alphabetically. Then the person, the metal. Then the rank, the oxidation state.
Now let's apply this masquerade ball logic back to our original problem. It's a very common mistake to look at the formula COClNH35 and think the name has to start with chloride just because Cl is written first. I see this all the time. It's an understandable mistake, but it breaks the most important rule of the system.
And here it is, the golden rule, the most important thing you must remember. The ligands are always listed alphabetically by their name. Always. The order that you see in the chemical formula, it does not matter for the name. The formula is just a writing convention. The alphabetical name is the absolute rule.
So let's see how the logic applies here. In our example, we have 2 types of ligands. We have NH3, which is named amine, and that starts with an A, and we have Cl, which is named chlorido, starting with a C. Now, since A comes before C in the alphabet, amine must be named before chlorido. It is as simple as that. And so we have our answer. The correct choice is A. We have 5 amine groups, so that's pentaamine, and we have 1 chlorido group. The metal is cobalt, with an oxidation state of IAI. Following our alphabetical rule, the correct name is pentaamine chlorido cobalt 3 ion.
All right, so that was the core logic. Before we finish, let's just quickly recap the most important points that you need to remember for your exam.
First, always remember why these rules exist in the first place. This is not just some random set of rules to memorize. It is a universal language, and it is designed for clear, unambiguous communication among scientists all over the world.
Now, if you ever feel confused, just use the mental images that we discussed. Think of the chemical name as a passport, or remember the masquerade ball. These analogies will make the rules feel much more natural and logical.
And remember, the most common mistake students make is naming ligands in the order they appear in the formula. So, you must master the golden rule. No matter what the formula looks like, you must always alphabetize the ligands by their name.
You know, if you just remember this one golden rule about alphabetizing, this topic will feel so much lighter and easier during your exams. So, I will leave you with one final question to lock it in your memory. What is the very first thing you will always do when you start to list the ligands in a name? Thank you for listening.